Now another measure of yield, which is actually a better measure of the yield, is called the yield to maturity, or the YTM. Okay, the yield maturity. So this yield to maturity, as the name suggests, is the yield that you will get if you hold the bond to maturity. And if you remember the general rule of finance, that you can price any security by taking the present value of its cash flows. Hence, the yield to maturity is the rate, okay, that will set the present value of the cash flows of the bond equal to the current bond price. Okay, so the cash flows of a bond, we will know, include the coupon and the par value at maturity. So what is the discount rate that will set the present value of these cash flows equal to the current bond price? Okay, current bond price. So suppose we have the coupons of a bond denoted by C. So coupon at year 1 and at year 2. So coupon 1, coupon 2, and at coupon N. Okay, at the end of year end, and at the end of year end we get a par value also. So these are the various cash flows of the bond. Okay, and to calculate the present value, we need to discount them by the discount rate, which is denoted by R. So 1 plus R for year 1, and discount for year 2 is 1 plus R and bracket square, and for N is 1 plus R bracket to the power of N, as well as for the par value. So the yield to maturity is this R. Okay, this R. What is the rate R that can discount all these cash flows such that it will equate to the current bond price? Okay, so this is the yield to maturity. So if you give a yield to maturity, it's equivalent to giving a price for the bond, which is the current practice in the bond market. Alright, so this is a very important value that you will notice that it appears everywhere, whether is it in Yahoo Bond Center or in the Reuters Wealth Manager. So the next question is, how can we calculate R? Okay, this looks like a humongous equation. How do we calculate R? Okay, we were not told how to do that in secondary school. Okay, we only worked up to the term R squared. So how do we deal with R to the power of N and so on? Okay, what we can do is we can use something called trial and error. Okay, we can use trial and error, which means we will try to put in a random value of R and see if using this random value of R we will get the bond price. Okay, we're able to do that because we already know what's the coupon rate, what's the par, and what's the bond price. So we just substitute a random value of R and see if it equates. If it doesn't, we'll just try another one. Okay, and we'll keep on trying until we get the answer. So this is called trial and error, which in our Excel VB assignment, later on we will demonstrate. Okay, we already know that for discount bond, okay, that is the current price is actually lower than the par value of the bond. Okay, the coupon rate will be less than the current yield. Okay, which means we enjoy a current yield, and in turn, this current yield is actually less than the yield to maturity. Okay, and also for premium bond, okay, we know that the coupon rate is more than the current yield. Okay, remember the premium bond is where you pay a higher price than the par value of a bond, and in turn the current yield is more than the yield to maturity. Okay, and for a par value bond, you have the coupon rate being equal to the current yield and being equal to the yield to maturity. So you might have a question, why would anyone want to buy a premium bond? Why would anyone want to pay a current market price that is higher than the par value? Why? Okay, for example, okay, the price of a premium bond is $1,100. the par value is $1,000 and the coupon is 7%. However, the current interest rate for a comparable bond with equal risk is actually 6%. So in this case, someone would be willing to pay a premium on the bond since it has a larger coupon rate than the current interest rate. And also, okay, if he predicts that the current interest rate would continue to decrease in the future, okay, and hence he would hold on to this bond with a higher coupon, okay, to enjoy a higher rate of return. Okay, so to summarize, the price of a bond can be calculated as, okay, a summation of all its coupons, okay, discounted, plus the par value and discounted, okay, where we have R as the discount rate, okay, and we mentioned that if this equals the price of a bond, this discount rate is actually our yield to maturity, and at T it's at different periods. Now this is for an annual paying coupon bond, okay, but if it's a semi-annual, we have to do some changes, because if it's a semi-annual bond, okay, the number of periods would be multiplied by 2, so it would be 2t, okay, from the first period to 2t periods, okay, and we will expect to have only half of the coupon, okay, alright, half of the coupon of the annual one, and it will be 1 plus also the discount rate will be, we would halve it, alright, and the par would remain the same, okay, but just R over 2 and 2t. Alright, so this is for a semi-annual where we have to adjust for a semi-annual bond.